Hello, this is Brian McCorkle, and this is a flash talk for Neuromatch 5 on Intuitionism and Neurophenomenology. So we'll start our talk by talking about two of the main people, or the main progenitors behind Intuitionism and phenomenology, and neurophenomenology, sorry. The first person you see here on the left is Francisco Varela. He's widely credited with the kind of articulation of neurophenomenology, particularly in 1996 in response to David Chalmers, which I'll get back to later. This is L.E.J. Brewer, who wrote primarily at the beginning and in the middle, a little bit of the 20th centuries, and is the founder of Intuitionistic mathematics and Intuitionistic logic. So what is intuitionistic math? Well, Wikipedia defines it quite well as an approach where mathematics is considered to be purely the result of the constructive mental activity of humans, rather than the discovery of fundamental principles claimed to exist in an objective reality. And I thought that was pretty good, even though it's from Wikipedia. It's good, gotta use it. So what are the implications of this, or what does this mean concretely? Well, there's a rejection of the law of the excluded middle, this idea that there can either be A or not A, but not both. In intuitionistic math, there can be both, and this puts it squarely in the camp of constructive mathematics. Intuitionism also comes in many flavors, including Martin-Löf type theory, other type theories, and as we'll see later, homotopy type theory. It also has this idea of the creating subject, which is identified in intuitionistic notation, or some variants of it, as this little box here, which we'll see again later. So our other topic, neurophenomenology, what is that? Up here you can see some kind of affectual displays of how kind of emotions come forth in the body. And this has to do with the 4 E's that we usually think of when we think of neurophenomenology, or at least when I think of neurophenomenology: inaction, experience, extension, and embodiment. These are kind of what neurophenomenology has become, especially these days, with a lot of inactive approaches and a lot of these 4 E's being considered important for what we talk about when we talk about this hard problem and when we talk about consciousness and the logic thereof, or what it is, or where it is. I digress. Another important thing that'll come up later about neurophenomenology is the idea of accounts of experience, the idea that we can have first, second, and third person accounts of experience. Who's talking, or who's receiving this experiential account. So if you recall in the last slide, I mentioned that there was this curious creating subject notation being used in intuitionism. In Francisco Varela's A Calculus for Self-Reference, written before the neurophenomenological turn, but certainly in a proto-autopoiesis kind of mode, he uses a very similar notation, and this one derived from an intuitionist himself, George Spencer Brown, who wrote also in the early 70s. Okay, on to the parallels. So the first parallel I want to look at are that both of these movements have transhistorical roots. For intuitionism, intuitionistic math, and intuitionistic logic, they trace their roots back to Stoic and Megaric logic, developed in Athens in almost 400 BC. So they trace themselves back to non-Aristotelian ancient Greek logic. And they've published several studies about that and have kind of established that, but not too directly in their writings about mathematics, but it's always kind of there lurking in the background. I thought that was very interesting, especially when you compare it with a book like The Embodied Mind by Varela, Rosh, and Thompson, who really spend most of the book trying to fold Buddhist perspectives and learn from the Buddhist tradition and what it can tell us about how we should be doing cognitive science. So the second parallel I want to talk about is that both of these ideas, intuitionistic math and neurophenomenology, privilege experience. This first quote is really good about intuitionism from the Stanford Encyclopedia of Philosophy. The truth of a mathematical statement can only be conceived via a mental construction that proves it to be true, and the communication between mathematicians only serves as a means to create the same mental process in different minds. So in intuitionism, this truth comes directly almost from interpersonal experience and interpersonal communication. It's that the mental process is there, but it's a mental process. It's not a fundamental part of reality. And this is very similar to neurophenomenology, which says that intuition is the basis of the criteria of truth in phenomenological analysis. analysis, the nature of its evidence. So neurophenomenology is almost built out of intuition. So it would make sense that we could use an intuitionistic logic to talk about it maybe more rigorously, which I'll get to at the end of this talk. So another writer, Mark Van Atten, makes a convincing argument that intuitionism is phenomenology, that it's basically the same thing, and that we can talk about them formally, almost identically, which is super fascinating, and I'm just getting into it, so I won't say much more about it here. The third parallel I want to talk about are that both of these have orders of expression, or give rise to these expressive tools for looking at complex problems. For intuitionism, as I mentioned earlier, it leads to homotopy type theory, formulated by the late Vladimir Voevodsky, which basically says that homotopy types can be used to describe forms of logic if you imagine those logics as topologies or as geometric shapes. So formal logic is homotopy type level 1, set theoretic logic is level 2, and category logic is level 3, etc. And this pattern of threes, which are kind of folded into each other, has parallels with neurophenomenological accounts of experience, which I mentioned a little bit earlier, and which you can see a little bit of here from the book on Becoming Aware. And then finally, they relate directly to cybernetics, which is always fun to talk about. I highly recommend reading Mick Ashby, not to be confused with his older relative. Mick Ashby writing about ethical regulators and these ideas that we need a model-centric view of systems rather than an observer-centric one that we find in Von Forrester. But that's another flash talk. To conclude this one, we've made some transdisciplinary comparisons across the fields of math and cognitive science. We've looked at some parallels between intuitionistic math and neurophenomenology. They both look to historical movements for inspiration and support, privilege experience, and have phenomenological aspects, even intuitionism does. And they also both provide expressive tools for researching complex formal questions, such as what is self-reference and how can we build a self-regulating system. So thank you very much for your time. I hope that looking forward, maybe we'll start to see NeuroIntuitionist logics of computation, such as A. Kavya and Brian Cantwell Smith have kind of implied and written about explicitly in Kavya's case. And by making these connections between these fields and others explicit, building these bridges, we can push research forward in this radical way, which is rigorous and formally defined. For more details, see a blog post I wrote on Medium, posted under the Orel group. And I also wanted to mention that this was inspired by research done with Orel, Orthogonal Research and Education Laboratories, Cognition Futures Reading Group, which is still open to new members. So visit this link down here, cognitionfutures.github.io, for more details. And thank you for your time, and have a great neuromatch.